Okay, this is the chapter 5 that we start in our last class. So I will do a quick revision of what we learned in our last class, and then we will continue. So chapter 5 about series. So in our previous class, we started do a quick revision about sequences and series. And we said that any order of numbers, we call it a sequence. Any order of numbers, we call it a sequence. For example, 1, 2, 3, 5, 9, this is a sequence, but this is a finite sequence because we already stopped at one number. From 1 until n here, also finite sequence because we stopped at a specific number n. But if we continue without stop, we call it infinite sequence. And we learned that we have two types of sequence, geometric sequence and arithmetic sequence. Arithmetic sequence, we keep adding the same number. For example, if we have 8, 5, 2, minus 1, minus 4, this is arithmetic sequence because we keep subtracting minus 3. We keep subtracting 8 minus 3, 5, 5 minus 3, 2, 2 minus 3 is minus 1, and so on. So D is minus 3. First term is 8, so the nth term for arithmetic sequence, the nth term can be calculated by this formula. A1 plus n minus 1D. This is the formula for arithmetic sequence. 8 is the first term. Minus 3 is the constant that you keep adding or subtracting. So 8 plus n minus 1 minus 3. And then we go for geometric sequences. Geometric sequences, you keep multiplying the same constant, not adding. You keep multiplying the same constant. For example, here 2, 6, 18, 54. This we keep adding. We keep multiplying minus 3. We keep multiplying minus 3. We keep multiplying 3. So we need to follow this formula. An is equal to A or n to the power n minus 1. The first term is 2, is A here. R is the number you keep multiplying. R is the number you keep multiplying, which is 3. Now 1 minus 2, 4 minus 8, we keep multiplying minus 2. This is also arithmetic sequence. So this is also geometric sequence because we keep multiplying the same number. Then we need to follow this formula to find the nth term. And then we learned the series, and we said that for any sequence we have a series. Series is the adding terms. We add the terms of the sequence. We have a sequence, we add the term of the sequence, then we have a series. We can get from the same sequence so many series. If I add one term, so I have a series from one term equal to 1, equal to the first term. If you add 2 terms only, you have another sequence as 2. If you add 2 terms of the sequence, you have another series as 2. If you need to get the series as 3, you need to add 3 terms of the sequence. If you need to get the series as 4, you need to add 4 terms of your sequence. So to get the series as n, you need to add the terms of your sequence from U1 until UN. So how many terms you add, then you'll be as the series Sn. The series Sn. The series S10, you need to add 10 terms of your sequence. The series S100, you need to add 100 terms of your sequence. And then we get some examples. For example, this sequence, this is arithmetic sequence. We find the nth term, and then we can find the fourth term, which is 10. the fifth term of the sequence, which is 13. And then from this sequence, this is a sequence because we have order of number. Between numbers, we have comma, not addition. So this is a sequence. Now we need from this sequence to find the series S4. To find the series S4, which means go for your sequence, add the first 4 terms. For S5, you need to add the first 5 terms, of your sequence. And then we have another example that we give the general formula for Sn. We give the general formula for Sn. And then we need to find the first terms of your sequences. So you need to calculate S1. This will be the first term. Then calculate the series S2. You will get by subtracting S2 from S1. You have the second term. Then calculate S3, subtract S3 from S2, you will get the third term of your sequence. The nth term of the series is same of the nth term of the sequence. So this is your sequence. After you find 3 terms, you have 4, 6.59. We found it is arithmetic sequence. So the nth term here will be following the formula for arithmetic sequence. And then we can denote the series by this symbol or this donation or this sigma. We call the sigma, summation, or sign. This is when you see this sign, you know this is a series, not a sequence. This is a series, not a sequence. And then we solve more than examples. The last example, we solve this one. And then we give the general formula for some series. The series R. This is the general formula for Sn. R squared is the general formula for Sn for R squared. And this is the general formula for Sn for R cubed. And then we evaluated. We solved some example. Now go back for the last example. We solve 1 times 3 plus 4 times 5 plus 7 times 7. We need to find this one, to write this one as a series up to 30 So the first sequence, 1, 4, 7. This is arithmetic sequence. This is the nth term for this arithmetic sequence. The second sequence, 3, 5, 7. We found its nth term. Also, it is arithmetic sequence. We found its nth term. Then we need to find the series by multiplying these 2 sequences. I have one sequence multiplied by another sequence, and I need to find the series of the multiplication. So the series of multiplication will be 3, the first nth term. For the first sequence, 3n minus 2, multiplied by the nth term of second sequence, 2n plus 1. So adding the multiplication, you have a series. This series, we add 30 terms. Then we found the summation of this series using the formula of R squared, R, and 2. We stop here. So now we need to find the series of 1 over 2 multiplied by 3 of plus 1 over 3 times 4. This is times again, not point. This is not 2.3. This is 2 multiplied by 3. This is not 3.4. It is 3 multiplied by 4. 1 over 4 multiplied by 5. And then we need to find the summation of this series. We need to find the sum of this series. So we need to start the solution here. Okay. We have 1. This is our sequence. 1 over 2 times 3 plus 1 over 3 times 4 plus over 4 times 5, and so on. We need to find the summation of this series. Okay, first we need to find the nth term of this series. I will do similar to the previous example. Take the first numbers 2, 3, 4. The first number 2, 3, 4 here. This is a sequence. This is arithmetic sequence. We keep adding plus 1. We keep adding plus 1. So this is arithmetic sequence. First term is 2. D here is equal to 1, the number you add. So the nth term follow the arithmetic sequence formula is equal to 2, the first number here, plus n minus 1, D is equal to 1. Is equal to 1. So calculating this, you have n plus 1. You have n plus 1. You have n plus 1. This is n plus 1. This is the nth term for the first sequence, 2, 3, 4. Okay, go back for the second sequence, 3, 4, 5. 3, 4, 5. So the second sequence we have 3, 4, 5. So this one also arithmetic. So we adding same number. So this is arithmetic sequence following the formula for arithmetic. So an will be the first term, which is the 3, plus n minus 1 multiplied by 1. Multiplied by 1, the number you keep adding. So this is n plus 2. This is n plus 2. This is n plus 2. So I found the nth term for the first sequence and the nth term of the second sequence. So what we need to do is we need to find the series of, because 2 times 3 plus 3 times 4 plus 4 times 5. So we need to find this series, n plus 1 multiplied by n plus 2. We need to find this one. We need to find the nth, this series, the nth term, or we need to find the summation of the first nth term of this series. So how we can do this? Now we cannot apply, like in our previous example, we directly apply, we multiplied and we apply the formula of r square and r and so on, this formula here. But in our example now, we couldn't apply, we couldn't follow the same method. I couldn't multiply and apply the series of r square and r and so on, because we have 1 over n plus 1 multiplied by n plus 2. So we will go to what we call difference method. What we call it, the difference method. Difference method means I will use the partial fraction. You know the partial fraction. I have this term 1 over n plus 1 times n plus 2. This is the nth term of your series. So I will use the partial fraction method. I will divide this fraction to smaller fractions. I will divide this fraction to smaller fractions. So here it should be a constant a and a constant b. So if you're finding the value of a and b by using partial fraction method, this will be equal 1 over n plus 1 minus 1 over n plus 2. 1 over n plus 2. If you find the value of a and b, it will be 1 over n plus 1 minus 1 over n plus 2. So again, what we need to do is need to finite this series. 1 over 2 times 3 plus 1 over 3 times 4 plus 1 over 4 times 5 plus 1 over n plus 1 minus 1 n plus 2. So I need to find this one. So I will start from the first series, 1 over n plus 1. 1 over n plus 1. Let me write the terms of this series. 1 over n plus 1. If I need to find the terms of this series, it is equal to, if I started from n equal for 1, start from n equal to 1 and stop at any number for example. Stop at any number. So the first term of this series is 1 over, substitute n equal to 1, so you have 1 over 2. If you substitute n equal to 1, here, substitute n equal to 1, because we need to find this series starting from the first term, 1. So starting from n equal to 1, so you have 1 over 2. You have 1 over 2 plus 1 over, substitute n equal to, because the first term 1 over 2. Now substitute n equal to, which you have 1 over 3 plus. Now I will substitute, first I substitute n equal to 1. Then I substitute n equal to, so 2 plus 1 is 3. Then I will substitute n equal to 3, which is 1 over 4. Substitute n equal to 4, which is 1 over 5. And so on. Until you reach, maybe if you confused, we can make it, just make it R. So because in the question they ask of the first n term, so we need to stop from term number 1 until term number n, not n. So until you reach 1 over, substitute r equal to n, so n plus 1. N plus 1. So the first series here, or the first we have is substitute this term 1 over n plus 1. So when n equal to 1 or r equal to 1, we have 1 over 2. When r equal to, we have 1 over 3. When we r equal to 3, we have 1 over 4. When r equal to 5, we have 1 over 5, until we reach n, which is 1 over n plus 1. Same for the second one, 1 over n plus 2, this one. I will repeat the same for 1. I will write the term. When r equal to 1, it should be 1 over 3. When r equal to, it should be 1 over 4. When r equal to 3, it should be 1 over 5. Until you reach 1 over n plus 1 plus 1 over n plus 2. N plus 2. When r equal to n minus 1, should be n plus 1. N minus 1 plus 2, which is n plus 1. When r equal to n, so we have 1 over n plus 2. So this is the term for the first series. This is the term of the second series. Now I need to calculate the difference. I need to calculate the difference between 1 over n plus 1 minus 1 over n plus 2. So to calculate the difference, it should be equal, we need to find the difference between the two series. So the difference between 2 equal to Look here, when I calculate the difference, I have 1 over 2 here, the first term, this first term. Now, 1 minus 3 will be cancelled with 1 minus 3. 1 over 4 minus 1 over 4 because here we subtract. Here we subtract. So 1 over 2 you have. So 1 over 3 minus 1 over 3 minus 1 over 3 should be 0. 1 over 4 minus 1 over 4 should be 0. So for sure this term should be cancelled. This term should be cancelled. When I do the subtraction, this term should be cancelled. This term should be cancelled. So you have, after you do subtraction, you have the first term here, 1 over 2, and the last term here. So this is, it should be equal to 1 over 2, the first term, minus 1 over n plus 2. 1 over n plus 2, and this is the summation or Sn for the series, the summation of Sn, the summation of the first nth term. So this is what you have. This is Sn. So again, I will repeat the example again. We need to find the sum of the first n terms of this sequence, which means you need to find Sn. You need to find Sn for this sequence. So you have 2 times 3, 3 times 4, 4 times 5, and so on. So first I need to find the nth term. The nth term of the series. Then I can find the addition. So the first step, you need to find the nth term. So here the nth term, the first sequence I have, 2, 3, 4, arithmetic sequence. I can find its nth term by using the formula. Okay, the second sequence, 3, 4, 5. 3, 4, 5. This is the second sequence. Now the second sequence, 3, 4, and 5, also arithmetic sequence. So we need to find its nth term using the formula of arithmetic sequence. If it is geometric, you need to use the formula of geometry. Here I have both sequence are arithmetic, so both sequence will follow the formula for nth term for arithmetic sequences. First one, n plus 1, second one, n plus 2. So this terms mean that we need to add 1 over n plus 1, n plus 2. Now how to find the addition here? We need to go to partial fraction. 1 over n plus 1 multiplied by n plus 2. Divide this fraction to smaller fraction. We need to divide this series to 2 smaller series. We will divide this series to 2 smaller series. So by using partial fraction, the value of A is 1. The value of P is minus 1. So this is your new series, our new 2 smaller series. So this series 1 over n plus 1, n plus 2 can be written as 1 over n plus 1 minus 1 over n plus 2. Okay. First series 1 over n plus 1. This series is equal, write its terms. It is equal to, when r equal to 1, it is 1 over 2. When r equal 2, it is 1 over 3. When r equal to 3, it is 1 over 4. When r equal to 4, it is 1 over 5. When r equal to n, it is 1 over n plus 1. Okay, what about the second series, 1 over n plus 2? 1 over n plus 2. So the first one, if I write its term, when r equal to 1, it is 1 over 3. When r equal 2 is 1 over 4. When r equal to 3, it is 1 over 5. Until you get r is equal to n. So you have 1 over n plus 2. Now subtract these two series, because here we need to calculate the subtract between these two. Subtract, you have 1 over 3 minus 1 over 3 should be give you 0. 1 over 4 minus 1 over 4 give you 0. 1 over 5 minus 1 over 5 also 0. So all these terms will be cancelled by subtraction. Only you have 1 over 2, the first term here, and the last term here. Minus 1 over 1. So this is the addition of these terms. So this is the Sn. So now we found in Sn is equal to 1 over 2 minus 1 over n plus 2. So the addition of the first n terms of this series or this series is equal to 1 over 2 minus 1 over n plus 2. 1 over, this is we call a difference method. Difference method by using partial fraction method. Partial fraction. If you have any question, you can ask, you can open your mic or you can ask on the chat. This is how we can find the sum of the series. How we can find the sum of the series. Now we need to know, if you look here, we need, when we find the sum of the series, all the series, we calculate the sum until nth term. We use nth term. For example, here we stop at 30. For a previous example, we stop at 10 terms and so on. Here we stop at 10. Previously, we stop at 25. So all the examples here, when we found the sum of the series, we stop at a specific number n. So the question is, if we have infinite sequence and we need to calculate the infinite series. The infinite series. So we need to add until infinity. Should we have a sum? Should we have a number if we adding infinite terms or not? If you have a number, then we say that it is converge. We say that the series converge. If the summation is not go for a number, this is a diverge series. So we have what we call test of conversion. Test of convergence, we need to check if I adding this series for infinite, I can get a number or not. I can get a number or not. We have 3 tests. The first test we call the divergence test. The divergence test. The divergence test, we need to calculate the limit for nth term. The limit for nth term. If the limit not zero, maybe infinity, maybe it does not exist, maybe any number, the most important thing, the limit not zero. The limit not zero, then we say the series diverge. The series is diverge. If limit not zero, I need to calculate the limit of the series. If I calculate the limit and I found that limit not zero, then we say that it is a diverge series. It is a diverge series. If the limit equals 0, then test fail. We cannot say it is converge. We don't know. If limit equals 0, that this test fail. We cannot apply this test to decide. Maybe converge, maybe diverge, I don't know. The most important thing is we need to know to calculate the limit. If the limit not 0, even it is infinity, even it is does not exist, even it's equal to number, the most important thing not 0. Then for sure this series is diverge. Otherwise it is converge. It is test fail. Test fail. For example here, series n squared over 5 n squared over 4. If I need to find it is converge or diverge, just evaluate the limit for n squared over 5. N squared plus 4 when n goes to infinity. When n goes to infinity. Just evaluate the limit when n goes to infinity. For n squared over 5, n squared plus 4. So here, direct substitution, you have infinity over infinity. You can apply L'Hopital rule by finding the derivative here over the derivative here, or another way, you can divide by the highest power. You can divide by the highest power. So you have n squared over n squared, 5n squared over n squared, plus 4 over n squared, plus 4 over n squared. So this will be equal to limit when n goes to infinity. N squared over n squared is 1. 5n squared over 5n squared, we have 5 plus 4 over n squared. 5 over n squared. Now direct substitution. Direct substitution, when n goes to infinity, 4 over infinity is 0. Any number over infinity is 0. Any number not 0 over infinity is 0. So you have 1 over 5. 1 over 5. 1 over 5. So the limit is equal to 1 over 5. The limit is equal to 1 over 5. This limit not 0, so this limit not 0. Not 0. So which means diverge. Which means according to the test, the series diverge. According to the test, series is diverge. We can say that series diverge. Series is diverge. Just evaluate the limit. Okay. Here another example. We need to use also divergent test to determine whether the series diverge or not diverge. Whether the series diverge or not diverge using divergent test. Divergent test means evaluate the limit. So I need to evaluate the limit when n goes to infinity, when r, so, because we have r here. For r over ln r. Okay, direct substitution here, you have infinity over infinity. Infinity over infinity. So we need to apply L'Hopital rule. We need to apply L'Hopital rule. So we have limit when r goes to infinity. The derivative for r is 1. The derivative for ln r is 1 over r. Is 1 over r. Is 1 over r, which is, just to rearrange, it is equal to limit when r goes to infinity for r. For r. So the limit for r goes to infinity for r when r is equal to infinity. Direct substitution is infinity. Is infinity. So the limit here is infinity. It's still not 0. It's still not 0. Since the limit is not 0, infinity maybe does not exist. Maybe numbers, since it is not 0, then we can say that series diverge. Series is diverge. Series is diverge. Also, I give you another one example. For example, if you have this kind of series, for example, this is example number C, consider it. If I need to find the series, if I need to check the divergence of this series, which is cos and pi, when n equal 1 to infinity, by using divergent test. Still, I need to use divergent test. Divergent test means calculate the limits. Calculate the limits. cos, and pi. So what do you think? Cos, if I do direct substitution, I have cos infinity. Cos infinity equal to what? Cos infinity equal to what? Direct substitution should be cos n equal to infinity, cos infinity. This will give you cos infinity. Cos infinity equal to what? Okay, it is actually does not exist, not undefined. It is doesn't, because cos and sine is always between -1 and 1. Always ranges between -1 and 1. So in this case, we have two limits. -1 is a limit and 1 is a limit. So in this case, we said that limit does not exist. Cos infinity and sine infinity limit does not exist. Does not exist. Limit does not exist, same, means not zero, so the series diverge. Series diverge. Anything you get rather than zero, then the series is diverge. If you get limit equal to zero, then we say test fail. We cannot decide if our series converge or diverge. So in this case, if your test is fail, you have to search for another test to check your series converge or diverge. To check if your series converge or diverge. The another test we have integral test. This one is the integral test. But this integral test, you need to be sure before going to apply this test, the function you have should be continuous, positive, decreasing function. If your function satisfies these three conditions, then you can apply this test. Otherwise, this test cannot be applied. This test is another, cannot be applied. Your function should be continuous, positive, and decreasing. Continuous, positive, decreasing. Then, if you have a function or the nth term of your series is continuous, positive, decreasing, then you can apply this integral test. You need to integrate, not to find the limit for nth term. Integrate the nth term. Integrate the nth term, and you will get improper integrals because you have infinity in one term. Then you need to find the limit. If the improper integrals converge, your series is also converge. If the improper integral diverge, your series diverge. Let's go for examples. I have 1 over r ln r. 1 over r ln r. I have this function, 1 over r ln r. Before applying integral test, we need to be sure that the function positive, decreasing, and continuous. Positive, decreasing, and continuous. First, it is positive because r starting from 2 until infinity. The values of r all are positive. R started from 2. R started from 2. So we have, and ln r, before, if r greater than 1, so it should be positive. So this term, for sure, it is positive. We have r started from 2 until infinity. So r is positive. Ln r is also positive. So all the term is positive. Secondly, it is continuous. It is continuous. So here we have 1r ln r, for sure is positive. And is it continuous or not? Now 1r ln r, this is our function, is discontinuous when r equal to 0. But r equal to 0 is not with our domain here because we started r from 2. This function is discontinuous when r equals 0. When r equal 0. But here r is from 2, not from 0. So 1 over r is continuous. We have no problem. Also, this function is discontinuous when r is negative, because ln at negative is undefined. But here r starting from 2 until infinity, so it is always positive. So ln r is defined. So this function is also continuous and decreasing. How to check if your function is decreasing or not? You need to find this is the functions. This is your function. Okay. 1r ln r. So this is your function. Find the derivative for the function and prove that the derivative less than 0. If the derivative less than 0, then you have decreasing function. If the derivative less than 0, then you have within this range from 2 until infinity. If the derivative less than 0, then it have decreasing. So here our function positive, continuous, and decreasing. So we need to apply integral test. Until now, I didn't apply the test yet. I need to check if we can apply the test or not. So since we have positive, continuous, decreasing, then we can apply the test. So by using integral test. Okay, integral test states that go for your function, integrate your function. From 1 until infinity. So this is our function. We have 1x ln x dx from x equal to until infinity. This is your function. Replace r by x. So you have 1x ln x. Replace r by x. And the boundary of your integration is the boundary of the series. The boundary of your integration is the same boundary of your series. Series here is from 2 to infinity, so your integration from 2 until infinity. So we have improper integral at infinity. Here. So this is, we have to replace the infinity by any constant t, 1x ln x dx, because we have improper integral. So you need to change the infinity. Here by any constant t. And then after you integrate, you need to evaluate the limit when t goes to infinity. You need to evaluate the limit when t, if the limit exists, then converge. If the limit does not exist, then diverge. First, we need to find the integration. First, I need to find the integration of 1 x ln x from 2 until t. We need to find the integration of x ln x from 1 until t. 2 until t. X ln x. So how we can integrate here? We can integrate using substitution method. Take q equal to ln x. Then du 1 over x dx. So 1 over x dx is du. So you have 1 over u du. 1 over u du. 1 over u, the integration of 1 over u is ln u, is equal to ln u, which is equal to ln u here, rewrite in terms of x, so ln x. ln x from 2 until t. From 2 until t. Ln x, we have the boundary from 2 until t. So you have ln t minus ln 2 minus ln 2. This is the integration here. This is the integration. Now you need to evaluate the limits. After you find the integration, you need to evaluate the limit when t goes to infinity. So limit when t goes to infinity, ln t minus ln 2 minus ln 2. So direct substitution, you have infinity minus ln 2, which is equal to infinity, which is equal to infinity. Infinity minus any number is infinity, or plus any number is infinity. But infinity minus infinity, no. Only infinity minus any number or plus any number, still we have infinity. So the limit here is infinity. The limit does not exist, or the limit goes to infinity, which means the improper integral diverge. The improper integral diverge, which means the series also diverge. This is diverge, so the series also diverge. So the series diverge. So here to apply integral test to check if your series converge or diverge, you need to integrate this function from 2 until infinity. Before applying the test, you need to check if the function you have here, or your nth term, positive, continuous, and decreasing. Be sure it is positive. Be sure it is defined at all points in your the range of the series here. Here from 2 until infinity. From 2 until infinity, this function positive and continuous. To check it is decreasing, find its derivative. If you try to find the derivative of this function, you will find it is less than 0. So it is decreasing. From 2 until infinity, it is less than 0, which means decreasing. Now since it is positive, continuous, decreasing, you can apply integral test. Integral test, integrate the function. The boundary of your integration is the boundary of your series from 2 until infinity. So this is improper integral. We have problem at infinity. Replace infinity by t, a constant, and then evaluate the limit. So first evaluate this integral. By substitution method, we found it is equal to ln t minus ln 2. Now take the limit when t goes to infinity. T goes to infinity. So we have infinity, which means that this improper integral is diverge, which means your series also diverge, because the series will follow the improper integral, Another example, when you have, for the second series, r over the square root r square plus 4. R over square root r square plus 4. So here, but we need to check the series started from r equal to 1 until infinity. From r equal to 1 until infinity. From r equal to 1 until infinity. So now before going to apply the integral test, you need to check your function is continuous, positive, decreasing. Continuous, positive, decreasing. So continuous, which means should be positive. Should be positive. From R1 until infinity, this one is positive. So we have R is positive here. R is positive for all terms here. R is positive. So which means that R over square root r square plus 4, for sure it is positive. And also it is defined because r square here, the square root have no problem. This is will not equal 0, and also r square plus 4 always positive. So this is continuous. This is continuous function. And if you found the derivative, if you found the derivative here, it should be less than 0. Less than 0, so decreasing. From r equal 1 to infinity, it is the derivative less than 0, which is decreasing. So the conditions here, so we can apply the integration method, the integral test. So by using integral test, integral test means that you need to integrate. You need to integrate your function. The function is x over x squared plus 4 dx from 1 until infinity. From 1 until infinity. X over x squared plus 4 dx from 1 until infinity. The boundary of your integration is the boundary of your series. The boundary of your integration is the boundary of your series. So you have x over x squared plus 4. Now take the substitution method. U is equal to x squared plus 4. Then du will be 2x dx. Or 1 over 2 du is equal x dx. So this will be first, because it's improper integral, I will replace infinity by t. So x over x squared plus 4 dx, limit t goes to infinity. So now we need to evaluate the integration first. We need to evaluate the integration first. So you need to evaluate the integration from 1 until t x squared plus 4 dx, which is equal to integration. X dx will be replaced by 1 over 2 du. 1 over 2 du over 1 plus 1 over square root x squared plus 4 is equal to u. So 1 over 2 integration u to the power minus 2 minus 1 over 2 du. So adding 1 minus 1 over 2 plus 1 is 1 over 2 is 1 minus 1 over 2 plus 1 is 1 over 2 divided by 1 over 2. So you only have square root of 2. So you only have square root of u. So this is integration is equal square root of u, which is square root x squared plus 4 from 1 until t, because the boundary of your integration from 1 until t. Substitute, then you have square root t squared plus 4 minus, substitute x by 1, so you have minus 5, square root of 1. Now take the limit when t goes to infinity. Take the limit when t goes to infinity. take the limit when t goes to infinity. So you have for square root t square plus 4 minus square root of 5. Square root of 5. So this one, direct substitution, you have infinity minus a number again, which is infinity. So also, again, limit does not exist. If limit exists, the series converge. If limit go diverge or not does not exist, then we say that series is diverge. Series is diverge. So this is how we apply integral test. This is how we can apply integral test. So we have two tests until now. The first test, diversion test. Diversion test just evaluate the limit. If limit not 0, if the limit not 0, diverge. If the limit 0, test fail. For integral test, you need to check to be sure that you have continuous, decreasing, and positive continuous decreasing function. Then you can apply integral test. Integral test, you integrate your function, you have improper integral. Check if the improper integral converge, your series converge. If the improper integral diverge, then your series is diverge. The last test we have, what we call it the ratio test. This is what we call the ratio test. The ratio test can be applied for any series. Instead, if you evaluate the limit for r squared or for the an, for divergence test, we find the limit for an. But here you need to find the limit or the limit of ar. But here you need to find the limit for ar plus 1 over ar. Ar plus 1 over ar. If you get a value less than 1 converge, greater than 1 diverge, equal to 1 test is fair. Equal to 1 test is fair. For example, the first one, series, we need to check this series converge or diverge. This series converge or diverge. I have AR is R squared over 4R. This is the AR. This is the rth term of your series. Now, AR plus 1, replace each R by R plus 1. Replace each R by R plus 1. So, R plus 1 square over 4 to the power R plus 1. Replace. Go for AR, replace each R by R plus 1. Replace each R by R plus 1. So then evaluate the limit for AR plus 1 over AR. Limit when R goes to infinity, AR plus 1 over AR, which is equal to limit when R goes to infinity. AR plus 1 is R plus 1 square. R plus 1 square over 4 R plus 1 divided by AR, which is R square over 4 to the power R. 4 to the power R. This is AR plus 1 over AR, which means it is equal to limit when R goes to infinity. R plus 1 square over 4. 4R to the power plus 1, it should mean 4R multiplied by 4. Now, we will convert the division to multiplication. I will convert the division here to multiplication. and I will reflect the another fraction. So will be 4 to the power r over r squared. Convert the division to multiplication, reflect the another or reciprocal the another fraction. 4 to the power r over r squared. So this is will be equal to the limit when r goes to infinity. Now r plus 1 square is r square plus 2r plus 1 over 4 to the power r multiplied by 4, 4 to the power r over r square. This one we expand. We expand r plus 1 square. Now 4 to the power r can be cancelled. 4 to the power r can be cancelled to the 4 to the power r. So you have limit when r goes to infinity, r square plus 2r plus 1 over 4r square over 4r square. So in this case, limit, we need to evaluate the limit. You can direct substitution will give you infinity over infinity. You can apply L'Hopital rule, or here you can also divide by the highest power. So divided by highest power you have is square, so divide by r square plus 2r over r square plus 1 over r square over 4r square over r square over r square. So this is equal to now r square, if r square is 1, 2r is 2 to the power r plus 1 over r square over 4r square over r square, which is 4. Here we have limit when r goes to infinity. Now direct substitution, this one give you 0, 1 over infinity also 0, so you have 1 over 4. 1 over 4. Okay, 1 over 4 is less than 1. 1 over 4 is less than 1. According to the test, if you have a number between 0 and 1, the series converge. If you have a number greater than 1, the series diverge. Equal to 1, it is 0. Okay, here the number you have should be positive because we take the limit of absolute value. I didn't put the absolute value here because we already are positive, but it should be have absolute value. So if you have any negative number, your final answer should be positive. So if you have a positive number less than 1, you have a converge series. So series is converge. Series converge. Less than 1 converge, greater than 1 diverge, equal to 1 test fail. Same here for the second one. R exponential minus R. R exponential minus R. We go here, R exponential minus R from R equal to 1 to infinity. So AR is RE minus R. AR plus 1 is R plus 1. E minus R plus 1. E minus R plus 1. So this one you have limit AR plus 1 over AR when R goes to infinity. When R goes to infinity. So limit when R goes to infinity 4. R plus 1, which is R plus 1, E minus R minus 1, because the negative is multiplied by R plus 1. The negative here is multiplied by r plus 1. So negative r, negative 1 over AR, which is RE minus R. So now we need to evaluate this limit. Here also all the values are positive. All the values are positive. So no need to continue with absolute value. So you have limit r plus 1 over r exponential minus r exponential e minus 1 over e minus r over e minus r. So this will cancel with this one. So you have limit when r goes to infinity, r plus 1 e r, r plus 1 e r, e minus 1 become below by e. Now the direct substitution, infinity over infinity, you can use L'Hopital rule or you can divide it by r all the terms. If we apply L'Hopital rule here, so we have limit when r goes to infinity. The derivative for r is 1. This one, e here is a constant, the e multiplied by r. This one, e multiplied by r. So you have e. So you have the limit is 1 over e. The limit is 1 over e. 1 over e still less than 1. So converge. So we have converge. We have converge series. We have a converge series. So to check if your series converge or diverge by using ratio test, you need to find the limit of absolute value AR plus 1 over AR. If the limit less than 1, converge, greater than 1, diverge, equal to 1, test fail. How to calculate AR plus 1? Just replace each R, because this is AR. This is AR. This is AR. To calculate R plus 1, replace each R by R plus 1. Replace each R by R plus 1. And then evaluate the limit. And then evaluate the limit. So here we have 3 tests to check if the series converge or diverge. We can stop here today for today.